That is limits. Limits of functions using numerical and graphical techniques. I didn't show you the actual. So, discuss the slope of a tangent line to a graph. A tangent line just touches in one spot, right? So if we had something like this, I need to pick a pen. So if we had a quadratic or a parabola, and this was the point, the tangent point would be like this, and it would run, and that line would only touch in one spot, right? Tangent. Secant is 2 spots. Investigate a limit using a table, investigate a limit using a graph. Now limits. If I can get you guys to understand what a limit is actually a really, really easy definition. It's hard to wrap your brain around for some people. So a limit is not what the value is at that x value, it's what it approaches. So for example, if I had a graph like this, and I asked you at 2, at x equals 2, what is the value? You would tell me 0, right? It would just be the y. Now, if I said the limit as x approaches 2, and say this is f of x, you would tell me it's 0. Not because the value at 2 is 0, but the value from the left approaches what? What y value? 0. And from the right it approaches what y value? 0. So the limit is 0. Because it's what it approaches. Now, how is that any different? Well, if I did this graph instead looking like this, so this was my graph, but here I had a point of discontinuity instead at 0. What would be my value of f of 2? Does not exist, right? You could put DNE, it's the only short form you can use. What would your limit be as x approaches 2? 0. This wouldn't change because it's what it's approaching from the left and approaching from the right. It's not what it actually is at that value. I don't know what they're doing over there. So the limit as x approaches 2 is what it's approaching. So another way I could do this is I could give you that same graph. So the graph goes like that. And then instead I also have a dot down here. So this is 2 again. So what would f of 2 be for this one? -4. Some people say it doesn't exist. No, it does. It's down here. F of 2 is -4. Do you see that? It's a dot down there. What's the limit as x approaches 2 of f of x? Still 0. Because from the left, it's approaching 0. From the right, it's approaching 0. So the limit is not what the actual value is. The limit is what is it approaching. Now, what if from the left and the right it approached 2 different values? You would have a left limit, you would have a right limit, but the limit of that value wouldn't exist. Okay. So the definition of a limit, we're going to go through that in greater detail. I just wanted to give you a glimpse of what the heck it could possibly be. So definition of limit. In mathematics, a limit is the value that a function or sequence approaches as the input or index approaches some value. Limits are essential to calculus and mathematics analysis in general, and they are used to define continuity, derivatives, and integrals. And so that is chapter 2, 3, and 4. That's your other chapters. So that's what we use it for. So here we have this limit. Now, what is this? Grade 12. What did we do? What unit did that fall in? Starts with an R. Rationals. Radicals is the square root function. Rationals is when you have.
Yeah, but I couldn't think of anything else.
Glad the test was not written. Okay, good. It was about 2 weeks. Almost 2 weeks ago. All right. So this is a rational function. We agree? What do we do when we're given a rational function? I'm going to ignore the limit part. What do? We have x squared minus 1 over x plus 1. What did you guys have to do? Simplify it. How do we simplify? Difference of squares. So we get x plus 1, x minus 1. On the bottom, we have an x plus 1. Now remember, your denominator, if it doesn't cancel off, is a vertical asymptote. Correct? Because x can't equal that value. Because if it equals that value, your denominator would be 0, and that's illegal math everywhere. Okay? Even Mars. Now, If they canceled off, it's no longer vertical asymptote, is a what? A point of discontinuity, right? So we know that these would cancel off. So I know I'm going to have a point of discontinuity at -1 and something. Do you remember how we got that something? Right. So we would go -1 minus 1, and we would get -2. We agree? So I know that I have a graph that is doing something on either side of -1 and -2, but -1 and -2 does not exist because that's a point of discontinuity. We agree? So, what is f of -1? Does not exist, because what is at -1? Is this point actually existing on the graph, or is there an open dot there? There's an open dot there, correct? The point of discontinuity, an open dot at -1, -2, yes? Okay? So on the one side of the graph, it'll be approaching it, and on the other side, it'll be leaving from there, correct? So from the left, it's approaching what value? -2, and from the right, it's approaching what value? -2. So that's why the limit is -2. Because it's what it is from the right and the left, not what the value is. F of -1 doesn't equal anything. It does not exist. And you can go DNE, because that is a mathematical term that is allowed. If you use DNE, it doesn't mean it does not exist in that. But the limit, as it approaches that, is -2. Can you type that graph into your calculator? So I want you to put this into your y equals. So if you have it into your calculator, you're seeing that a lot of your calculators, remember, you can't see that point of discontinuity. It makes it look like it's actually closed. That's just what they do. But you know that if you went to second graph or to the table, it would have -1 error, correct? So we know that there is an error there, but we don't actually need to use our calculators to know that. We did 30-1 and we did it well. So we know what an actual graph looks like. So we know that from the left and from the right, it's approaching -2, yes? But there's an open dot there. So just because f of -1 does not exist doesn't mean the limit doesn't exist. The only way a limit can't exist at a value is if we had something like this. If we had this going like that, and then this going like that. So this from the left, it would be approaching 2, and from the right, it would be approaching -2, let's say. Then the limit at that value wouldn't exist. So they have to approach the same from the left and right in order for that limit to exist. If there's a gap, it can't exist. Okay? So we don't actually care what the value is at that dot. We don't care. In this case, we had to find out what it was, because that led us to know what the heck that y value actually is where they're approaching, right? Because it's an open dot there. Yes? So how do we write this in words? We say the limit as x approaches -1 of the graph x squared minus 1 over x plus 1 is -2, something in that form. So this means the limit as x approaches, that little arrow means approaches. As x approaches -1, so that means from the left and the right, what the heck is my y? Okay? So we're in section 1.1. I'm going to have you guys see what this does. So can you go to section 1.1 in your textbook if you have it? If one person has it out, share it with everyone and let everyone see what it is. So we're going to go to 1.1. I don't remember what page. Okay. So you are going to be... Okay, can you look at page 86 in your textbook? So that's where section 1.1 assignment starts. Section 1.1 assignment starts on page 86, correct? Now, if you flip ahead till you get to a section that I believe is green. Keep going until you hit a little bit that's green right now.
Oh,
There it is. So green is on 90. Do you see that?
yes.
Those are the AP practice problems. So if I say in here now, try AP practice problem 7, that's the green questions in that section. Okay? If it just says, like down here, now try problem 9, that's just the normal problems 86 on, right? So AP practice are the green questions. If it just says problem whatever, it's the other one. So, can you go and try this one quickly? It's on page 90. Remember that if you have some sort of function that is continuous, if you have a continuous function, your limit at that x value and your value at that x value will be the same, will they not? So if you have a continuous function, say you had a cubic function, does it matter where I ask you where the limit is? It'll be whatever that value is, won't it? So if I asked you at -3, your limit and f and x equals -3 will be the same. At 0, your limit and x equals 0 will be the same. The only time it's not the same is when you have a function that is not continuous. So for example, if I gave you that one, same one, and instead of having it continuous, I put an open dot here, then that wouldn't exist there, right? I could put a point down here even. So it's not a continuous function. So the only time your limit and f of whatever might not be the same is when your function is not continuous. So polynomial functions are continuous, right? Degree 1, 2, 3, 4, quadratics, cubics, linears, those are all continuous. So your value at f and your limit will always be the same. It's only when you don't have continuous functions. So let's look at this one here. The limit as x approaches 2 of 2x plus 5. What kind of equation is that? Linear. Is linear continuous? Yeah. So if I found f of 2, would I actually get the same value? Yeah, let's see it. So we'll go f of 2. F of 2 is 2 times 2 plus 5, and I get 9. So in my table, f of 2 would be 9. Now it's continuous line, isn't it? So as I approach 2 from the right, or from the left and from the right, as I approach 2, it's going to equal 9 because it is 9, right? So they'll be the same. Now they want you to be able to do it with an actual calculator as well. So a linear function is a little easier. We know linears, we know quadratics, cubics, exponentials, all those things are continuous functions. So let's go here. We're going to go type this one into our y equals now. So remember I told you you have to be able to do it verbally. You have to be able to do it with a table, numerically. You have to be able to, or graphically. You have to be able to do it numerically, which is algebraically. We have to be able to do all the different processes because that's how they can hand them to you. So we're going to type this one into our calculator, just 2x plus 5. Everyone typing it in? Now we need the answers for these ones. Now why do you think I picked 1.9, 1.999, 1.999, 1.99999? Why do you think I picked those? From which way? From the left. 1.999 is extremely close to 2, but not 2. From the left, correct? What about 2.0001, 2.0001, right? As I go this way, I'm approaching 2 from the right, getting really, really close, but not touching it, correct? How do I get the values there? Well, I type 2x plus 5 into my calculator, and then I do second trace value, and I can type them in. So we're all practicing it. 2x plus 5, and then I go second trace value. The great thing about it, this is the only one where you don't have to press second trace value 800 times. You just press second trace value once, and I go 1.99, and I get 8.98, and then right away I just go 1.999. I don't have to keep going second trace value each time. Now I go 1.999, and I get 8.998. Eventually you're going to start seeing a pattern. 1.9999, 8.9998, and then this would be 8.99998, right? And then we go 2.00001, 9.00002, 2.0001, 9.0002. This would be 9.002. This would be 9.02. So, if you look As I'm approaching from the left, what value am I approaching? 9. Do I actually care about this value currently? No. I shouldn't care about that value because if I'm talking about limits, I'm actually not talking about the value at 2. I'm talking about the values that I'm approaching it. So from the left, at 8.9998 is approaching 9. From the right, 9.00002 is approaching 9. Correct? So the limit as x approaches 2 of 2x plus 5 equals 9. And that would be your answer. Now you have to go limit as x approaches 2, little arrow down here, and then this value is straight with the word limit, equals 9. So you're going to try problem 9. Is this AP problem 9 or problem 9? Problem 9, so it's not in the green. It's in the questions right before the green. So go quickly do that. So, left-handed limits. If you look, it has a little negative. Do you see how there's a little negative here? That means from the left, not rocket science. It just means the value's on the left of it, and this means from the right. Now remember, the limit as x approaches c from the right of f of x equals the limit as it approaches right. So it's how you write it, how you read it, sorry, is you say, for this one it'd be, the limit as x approaches c from the right of f of x is, and then you'd say 7, 10, whatever it may be. Now if the right and the left approach the same values, remember that? If the right and the left approach the same values, then the limit at that value exists. If not, you have one-sided limits, but you may not have a limit at that actual value. All right. So we're going to go look at this one. Type that one into your calculator. We're doing a table for this one. So you type in e to the x minus 1 over x. E to the x is 81781. E is just a common base that's used in a lot of word problems. So your E button is behind ln. So ln, ln, is log base E. So I'm just going to show you. Stop panicking. So if I give you ln of 6, that can be written as log base E of 6. These are the actual same thing. Just trying to prove this to you. Okay? Now, why do they come up with some random ln instead of log base E of 6? Because log base E is used in so many different sciences where it's a common base, just like pi. 3.14159, it keeps going on. It's a non-terminating decimal. E is the same thing. And it's one that's used a lot. Pi is used a lot in circumference and area and all that stuff of circles, correct? Lns are used other ways. So E is just second that. So if you see there's log button, then below it there's the ln button. You just do second ln, and an E will pop up. So you do second ln, which is above or below log. And now we have to do e to the power of what? X. If you have the old calculators, you need to close the bracket, and then minus 1. If you have the old calculators without the fraction button, you're going to have to go e to the x minus 1 divided by x. You have to put it in brackets, right? If you have the ones with the fraction button, you can go alpha y equals enter and pop the fraction up. So remember, if you have it, you can go alpha y equals enter, or for the ones like that, you can just go alpha link, one beside it. Okay, so we're doing this again. Second trace value, starting at negative 0.01. I get 0.9950, and it keeps going. Then I go negative 0.001, 0.99950, then negative 0.00001, 0.99995. This will be 0.99995. What about 0? Why doesn't it exist? you're dividing by 0, look at your x value. Where is your x? Your x is in the denominator, so what can't x equal? X can't equal what? 0. If it equals 0, my denominator would be 0, correct? So this is a DNE. If you press 0, you'll see that y equals nothing, right? It gives you no value. And then you do 0, decimal 0, 0, 0, 0, 1. I get 1, 1, 2, 3, 4, 5 zeros and a 5. 1, 2, 3, 4 zeros and a 5. 1, 2, 3 zeros and a 5. Now to prove that a limit actually exists, we have to prove from the left and the right it approaches the same thing. No, I was plugged in. So, remember, if you put it into your calculator as a fraction, guys, remember this. You put it as a fraction, your answer is going to come out as fractions. So if you use the fraction button, your table will come out as fractions. So if you want decimals, type it in like this. Okay. So if we go and approach it from the left, what's it approaching? What is 0.999995 we're getting really close to? 1. So I'm going to say the limit as x approaches 0 from the left, which means that little negative sign, of e to the x minus 1 over x equals 1, correct? That's from the left. Then I'm going to do it from the right. The limit as x approaches 0 from the right of e to the x minus 1 over x, it's going to equal 1, because 1.0005 is getting really close to 1, correct? Now from the left and the right, do they approach the same thing? Yes. So then I can say, therefore, and you use this in math, the 3 dots that make a triangle, that means therefore in mathematics terminology. If you use proofs, you'll see it. Therefore, I'll make them a little bigger because they're kind of tiny. It's just a triangle, 3 dots. That means therefore, the limit as x approaches 0 of e to the x minus 1 over x equals 1. So if you want to prove that the limit exists for that value, you'd actually have to prove from the left it is the same value, from the right it is the same value, therefore at that value it's the same value. So that 3 little dots means therefore. All right, so I want you to do this. Problem 13, AP practice problem 6.